Hello! Today we're going to be looking at the first part of section 9.3, focusing just on making a unit circle. And a unit circle is a circle with a radius of 1. Now, if you have access to a printer, you can look at the PDF that I'm going to post and you can print out this diagram and mark all of this on the diagram. But if not, you can make your own circle, either by using a compass, maybe you have one from your geometry days, or grab the lid from something in your home, or a bowl or whatever, and trace it to make your circle. All right, there's my circle. And as best you can, mark about where you think the center is. It doesn't have to be perfect, okay? You're just going to do your very best with today's notes. Feel free to hit pause as many times as you need to, okay? And you might, if you have some colored pens or pencils, might find it helpful to do some color coding today. But if not, you could do this all in pen or all in pencil. It's totally up to you, okay? I'm going to divide my circle into half as best I can, right down the center here. I'm going to be labeling different parts of our circle with their measurements in degrees and radians. So kind of building off of what we were talking about last week of ways of measuring angles. So this angle right here would be 0 degrees, or that would be the same as 0 radians, okay? And you can abbreviate radians as RAD. Radians are rad. We also talked about last week how one rotation around a circle is 360 degrees, which is the same as 2 pi radians. Okay? So halfway around is 180 degrees, or pi radians. And now we're going to have a little fun with fractions. I know they're your favorite. You're going to love me so much today. All right. Okay. So if this is 1 pi, then this little piece right here is half of that. I should back up. Okay, so we know this is half of 180, so that's going to be 90 degrees. And half of pi is going to be pi over 2. Okay, that's the way we're going to, instead of writing 1/2 and then the pi, we put the pi on top of the fraction. We put the 2 in the denominator of the fraction. Okay? So here we have half of pi, 2 halves of pi, which is a whole pi. So if I add another piece here, half of pi, 2 halves of pi. Ooh, I have 3 halves of pi. So this spot right here, 90, 180, this is going to be 270 degrees, or 3 halves pi. 3 pi over 2. Okay. And then if we added a fourth piece, 4 halves of pi, 4 over 2 is the same as 2 pi. Okay? All right, let's try a different fraction. Oh, I suppose I could have marked this spot right here. Talking to myself, even from at home, I'm talking to myself while I'm taking the notes, right? All right, so this is, let's see this, half of 90 degrees. Well, half of 90 degrees is going to be 45 degrees. Okay? And if you can see, so I've divided pi up into 1, 2, 3, 4 pieces. So this is going to be a fourth of pi, or pi over 4. This spot right here would be 2/4 of pi. Well, 2 over 4 is the same as 1/2. This spot right here, so 45, 90, halfway in between 90 and 180 is going to be 135 degrees. And that's 1, 2, 3/4 of pi, so 3 pi over 4. Okay. We can keep going. So 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4. So this spot right here is going to be 5 pi over 4, if we're measuring in radians. Or 180 plus another 45 is going to take us to 225 degrees. All right, so 5 pi over 4, this was 6 pi over 4, which is the same as 3 pi over 2. This right here is going to be 7 pi over 4. And since each of these is 45 degrees, 270 plus another 45 takes us to 315 degrees. And then we'll be back at 2 pi. But that's not the only useful fraction on our unit circle, fraction of pi. So let's take a look at another one. All right, so this time I took that 180 degrees on the top half of my unit circle and I divided that up into 3 pieces, or so that would be 180 divided by 3 is going to be 60 degrees. And so 60 plus another 60 is going to be 120 degrees. 180 plus 60 is going to take us to 240. 240 plus 60 would be 300 degrees. 300 plus 60 is back to our 360. In radians, we took pi and we divided it into 3 pieces. So this is going to be 1 pi over 3. This spot right here is 2 pi's over 3. We've already marked this one. 3 over 3 is 1 pi. So here we have 4 pi over 3. And our next one would represent 5 pi over 3 and back around 6 pi over 3. 6 over 3 is 2 whole pi. All right, we have one more fraction that we need to look at that's important for our unit circle. Didn't cut quite as well this time. All right, so this time I've divided my pi radians, or my 180 degrees, into 6 pieces. So 180 divided by 6 is 30 degrees. So 30 degrees plus another 30 is 60. We've got that one already. 60 plus 30 is 90. We've got that one. 90 plus 30 is 120. Got that one. 120 plus 30. Oh, we don't have this one marked yet. That's 150 degrees. All right. And if we keep going, and I didn't make enough little pieces, so we're just going to kind of estimate, but 150 plus, or sorry, we're at 180. 180 plus 30 would be 210 degrees. 210 plus 30 is 240. 240 plus 30 is 270. 270 plus 30 is 300. 300 plus 30 would be 330 degrees. And if we add our radians to this, we took pi and we divided it up into sixths. Okay, so this is going to be 1 pi over 6. This was 2 over 6, but this one's already marked. 3 over 6, 4 over 6, 5 over 6. So this one, 150 degrees, is the same as 5 pi over 6. Okay? If I were to keep going, let me sort this out. All right, so this was 6 over 6. So our next one here is going to be 7 pi over 6. 8 over 6, 9 over 6, 10 over 6. Okay, so this last one here is 11 pi over 6. Feel free to hit pause right now if you need to take a moment to catch up. Okay, but our goal is that you have labeled all of these angles with their measures in both degrees and radians. Next up, we want to talk about some special measurements for these. And so I'm going to have to move my paper around a little bit here. Show you something that you don't have to write down this part just yet. Okay? But if I took a square and I cut it in half this way, and say in this particular square, so now I have a right triangle here. Right? This would be 90 degrees, and since I cut this 90-degree angle in half, these ones would each be 45 degrees. Well, if each side of my square was 1, then we could find this side here using our Pythagorean theorem, side C. That looks a little bit better to me. All right, so a squared plus b squared equals c squared. So 1 squared plus 1 squared equals c squared. Well, 1 is just 1. So 1 plus 1 equals c squared. 2 equals c squared. So c, we took the square root, was equal to the square root of 2. So as a reminder with your special right triangles, in a 45, 45, 90 triangle, if the two legs have a sides of 1, then the hypotenuse has a side length of square root 2. Now, if we were to take an equilateral triangle and just pretend that that actually looks equilateral, okay? In an equilateral triangle, right, each of our angles are the same and our sides are the same. So each of those would be 60 degrees. Well, say I cut that triangle in half. So this angle here is still 60 degrees, but since I cut that one in half, it would only be 30 degrees. But now, if this little piece here is 1, then all the way across would be 2. So this side here would be 2. And, well, let's figure out what this side is. I'll call it side B for right now, since it's not my hypotenuse. So using a squared plus b squared equals c squared, 1 squared plus b squared is equal to c, 2 squared. Well, 1 squared is 1. 2 squared is 4. If we subtract 1 from each side, we're going to get b squared equals 3. And if we take the square root, b is equal to the square root of 3. I'm drawing this a little bit differently than I drew it in that picture, but that's okay. So in a 30, 60, 90 triangle, the side opposite, if the side opposite the 30-degree angle is 1, the hypotenuse is 2, and the side opposite the 60-degree angle is square root 3. Oops. Let me just move my paper around accidentally just for fun. Not really just for fun, but it happens, right? We're going to make a little table to show sine, cosine, and tangent for some of these numbers as they relate to our unit circle. Let's use a different color. So we want to do 0 degrees, which we saw is also 0 radians. We're going to do 30 degrees. I guess I don't really need the degree symbol since I've already labeled it, which was pi over 6. I'm going to do 45 degrees, which we saw was pi over 4. 60 degrees, which we saw is pi over 3. And we'll do 90 degrees, which is pi over 2. I guess I made my table a little bit longer than it needed to be. All right. So let's start with the 45. Okay, so that's really using this triangle here. So I have 45, 45, 90 triangle. And from this 45 degree angle, sine is opposite over hypotenuse. So my opposite side from this angle is 1 over my hypotenuse is square root 2. But if you recall from last week, we don't like to have a radical in the denominator. So this is where we would multiply by square root 2 over square root 2, or just type that into our calculator, and we would get 1 times square root of 2 is square root 2 over square root 2 times square root 2 is square root of 4, which is 2. Cosine is adjacent over hypotenuse. Well, our adjacent side is 1 over our hypotenuse is square root 2. Okay, and we just saw that's going to give us square root 2 over 2. And tangent is opposite over adjacent. So from our 45 degree angle, our opposite side is 1 over our adjacent side is 1. Well, 1 divided by 1 is 1. All right, let's do 60 degrees right now. So here we have a 60 degree angle. Sine is opposite over hypotenuse. So from our 60 degree angle, our opposite side is square root 3 over our hypotenuse is square root 2. Hey, that one's already simplified for us. That's nice. Cosine is adjacent over hypotenuse. So our adjacent side is 1 over our hypotenuse is 2. So 1 over 2. And tangent is opposite over adjacent. So opposite is square root 3 over our adjacent side is square root 1. Well, square root 3 divided by 1 is square root 3. Okay. Pardon me. Now, for our 30 degree angle, hey, we can just go to this other angle in our triangle here. Sine is opposite over hypotenuse. So opposite is 1 over the hypotenuse is 2. Cosine is adjacent over hypotenuse. So our adjacent side to the 30 degree angle is square root 3 over our hypotenuse of 2. And tangent is opposite over adjacent. So our opposite side is 1 over our adjacent side is square root 3. Ooh, we've got a radical in the denominator, so we've got to fix that. We've got to rationalize it. So if you multiply by square root 3, we end up with 1 times square root of 3 is square root 3. Over square root 3 times square root of 3 is the square root of 9, which is 3. So those ones are pretty nice and friendly. But hey, I've got these other two columns here that we haven't talked about yet. And we don't have a special right triangle for how do you make a triangle with a 0 degree angle? Well, it turns out that these actually relate back to our unit circle. If I were to actually draw in a right triangle here, okay, pardon me. In this right triangle, we just saw that that if, I'm looking at the wrong piece, if this side, the side opposite of our 30-degree angle was 1, and this side would be 2, and this side would be square root 3, right? Well, in a unit circle, our radius is 1. That's the definition of a unit circle. Okay? So if this long side is 1, then this side would be half of that, right? That's the short side. And this side would be half of square root 3 or square root 3 over 2. Now, if we think about this as a graph, because that's really what we're working towards, is graphing this, okay? If I was to write the coordinates of this point right here, right, my x coordinate, how far I went in the x direction, square root 3 over 2. I feel like that's hard to see that that's a 3. I know. Luckily, I was using a pencil. And my y coordinate here would be 1/2. And notice, let's see if I can, right, that my y coordinate at this spot is the same as the value of sine in my table. My x coordinate here, square root 3 over 2, is the same as my cosine value from my table. So even if we don't have one of our special triangles, we can figure out our sine and our cosines because our cosine is going to be the x coordinate and sine is going to be the y coordinate. So if this is a unit circle with a radius of 1, then right here, at this point right here, my x coordinate would be 1 and my y coordinate would be 0. And if x is the cosine, then the cosine of 0 is 1. And since sine is the y coordinate, that would be 0 at that spot right there. The other thing you may have noticed as you were looking through our table here is that another way to get our tangent value is to divide our sine by our cosine, right? Square root 2 over 2 divided by square root 2 over 2 also gives us 1. If we have square root 3 over 2 and we divide that by 1/2, you would get square root 3. So if we do 0 divided by 1, our tangent of 0, 0 divided by 1, equals 0. So now we've just got one last column to do up here at 90. Now again, this is a unit circle. If our radius is 1, then here, my x coordinate would be 0, and my y coordinate would be 1. So x, my cosine, is 0. My y coordinate there, my sine value, is 1. And to figure out my tangent, if I do sine divided by cosine, or y divided by x, 1 divided by 0, we can't divide by 0. Hopefully you remember that's undefined. If you haven't ever done it, you should ask Siri what 0 divided by 0 is. It's often kind of hilarious to listen to her. Please don't stress out if not all of this made sense to you. This is just an introduction. Do your very best to have followed along and to get this written down in your notes. Your assignment for today, for this week, is just to send me a picture of this in your notes.